In this video, we show you how to extract results from a physics simulation. This is the last step in the workflow using our lug component. When the results are first loaded, the von Mises stress contour is displayed. We will show you how to edit some of the settings for this plot. We click on the options icon and change the scale factor for the deformation to 1. Then, we click on the rendering icon and turn on the mesh edges. Next, we will edit the maximum and minimum values of the contour range. We set the maximum value to 310 megapascals, which is the yield strength for 6061 T6 aluminum. Regions with a value greater than 310 are shown in gray. Clearly, the part is experiencing some yielding. We can use the View Cut app to see how much of the cross-section has exceeded the yield stress. We can modify the properties of the view cut. And drag the arrow to move the view cut up and down. When we are finished, we deactivate the cut. By hovering over a node, we can see the value at that location. Next, we will activate the displacement plot by double-clicking on it. Notice that, in the tree, the von Mises plot now has the red symbol, indicating that it is inactive. The options for the displacement contour are very similar to those of the stress contour. We change the scaling factor to 1, and click on OK. Notice, when we enable the von Mises stress contour again, our previously defined options are retained. We would like to get an understanding of what regions of the model are in tension and compression. To do this, we will create a new contour. We select the tensor component 1 as the quantity. This will plot the stress in the x direction. We need to change the legend values so we can better visualize the stress in the x direction. We change the maximum to 310 and the minimum to -386. The value input for the minimum is the bearing yield strength for 6061 aluminum. We can now clearly see that a significant region of the lug has a tensile stress greater than the yield strength. Sometimes, we also want the results in terms of an XY plot. We will plot the displacement at the center of the ball. For the support, we select Node Sets from the drop-down, and then select Node 1. We select Translations and Rotations as the output variable, and the vector component 3 as the quantity. This creates a plot of the z displacement at the center of the ball as the load is applied. Sensors are another great way to see results. We want to use a sensor to extract the reaction forces for the pinhole. So, we select the reaction force template. We can then select the proximity group that we created in the model creation video. We want the sum of the reaction forces for the nodes in this group. Specifically, we want the reaction forces in the x direction and the z direction. We output both of these values. The sensor results for the pinhole are now displayed in the model tree. We can extract results even if we did not define a group when we created the model. We must first define a display group. We create a new display group named bar nodes. Then we select the node set, adjective bar edges, and click on Replace. Now our display group consists of only those nodes. When we create the sensor to extract the reaction force, we can now select this new display group. Once again we use the reaction force template, and the vector component 1, as the quantity. Then, we simply select the display group that we just created. We want the sum of the X reaction force for the bar edges. We have now extracted all of the reaction forces for the pinhole and the bar edges. Next, we will demonstrate how to export a report of your simulation model, scenario, and results. Before we create our report, we need to activate the default display group for our current stress plot. With the full model displayed, we can navigate to the Report tool. We can click on Recreate. With all the items selected, the report will include the key things from our model, our scenario, and our results. The report is output as a Word document. Notice, the report includes the XY plot of the displacement of the center of the ball, and the sensor results for the reaction forces. By default, the Word file is stored in your Documents directory. We can also store a lightweight set of simulation results that can be viewed using 3D Play or the Physics Simulation Review app. We do this by selecting the Experience Content tool. We want our lightweight results to include the contour plot of stress in the X direction and the mesh. We click on Save and Produce. This only saves our settings and produces the lightweight results. That is exactly what this warning message is indicating. So, we must click on the Share button and select Save All. We have now completed the physics simulation results for the lug component.